Hello. Can you guys hear me? Okay, awesome. Okay, I'll probably get started in a couple more minutes. Hello. Can you guys hear me? Okay, sounds good. So I'm going to get started now. Today we are going to be going over the first module of our content for Bit University's data science curriculum. My name is Amy, and I'm going to be covering today's content as well as Thursday's pair programming homework session. But today we're going to be covering the first part of Module 1. So you guys can feel free to text or comment inside of the chat box if you guys ever have any questions, and I'll keep checking over there regularly to answer any questions that you guys might have. But yeah, let's get started. So we are part of BIT Project, and our program is BIT University. And our goal is to provide an interdisciplinary curriculum to help humanities students learn more about data science. So for this curriculum that we have, we're trying to make it as beginner-friendly as possible for students who have little to no experience in programming. And we're going to be covering some of the more introductory content of data science, so that students can have the resource tools and knowledge that they need to go into to apply for positions in research in any field that they want. So let's get started with today's presentation, which is an introduction to Python. Yeah, so the first thing that we're going to be going over is an introduction to what data science is and what programming is and why it's important for what we want to do. So what is data science? Data science is a field of study where we can be able to analyze data and form meaningful conclusions out of the data sets that we are working with. So for example, in this class, we're going to be learning how to sort and filter out data, so we can pick and choose which data that we need and which data that we don't need for whatever problem we're trying to solve. And then also we'll learn how to generate visualizations. And this just means coming up with graphs or like a better way to visualize text-based data that might be hard to understand some of the time. And also we'll be covering some methods and functions to get meaningful conclusions and analysis from whatever data we're working with. And this can be applicable to many uses of everyday life and to many fields as well, not just like computer science. So some examples where data science can be used are, for example, in Netflix. Netflix is a streaming service, and data science can apply to this case because they'll be needing to analyze watch times and user preferences to decide which shows to buy and like which shows to recommend to different users. Data science is also useful for people in the healthcare services because they'll need to study like virus cases and then decide which policies are needed to be enacted at specific times. And also for stockbrokers, they'll need to analyze stock performance to decide which stocks to buy or sell at specific times. And there are lots of other real-life applications for this as well. So that's kind of what data science is and how it can be used in many different fields. So what is programming? Programming allows us to analyze data easily and efficiently. So with just a few commands, we'll be able to filter out useless data and also select specific data that we want to work with, and visualize text-based information to get graphs and more easily understand the data that we're working with. Some examples of programming languages can be Python, Java, C, C++, C#, and many other ones as well. But for this class, we're going to be using Python. And the reason for this is that Python is a really popular general purpose programming language. And it's very beginner friendly as well because it's really easy to read and write, and that makes it easy to understand. And it's used for many different types of projects, such as data science, software engineering, web development, and lots of others as well. So because of this, we are also picking Python in particular because it has a lot of built-in data science libraries, and this has many built-in functions that we can use for whatever projects that we want to work with. So that was kind of a background about what this curriculum is trying to do. Does anyone have any questions really quickly before we move on to main content? You guys can like unmute yourselves or type in the chat box if you have any questions. All right, so I guess we're gonna get on with the content. So like I said earlier, today we're going to be going over a quick introduction to Python. And this is kind of an overview of what we're going to be covering. We're going to talk about some different data types, such as numbers, strings, Booleans. We're also going to be going over comparison operators, as well as if-else statements and lists. So for our first topic, we're going to be going over numbers. Yeah. So in Python, we have two different types of numbers. One of them are integers, and these are whole numbers. So for example, we can have whole numbers such as 3, 100, or negative 2,000. We also have floats as a different data type. And floats are just numbers that have decimals. So this can be like negative 3.14, or 2.917, or 1.1. And in Python, it's really easy to perform basic math with either of these types of numbers. So for example, we can perform basic arithmetic, such as addition, subtraction, multiplication, and division. And the way that we would do this in Python is very similar to how we would do this just in math normally. We would use these operations, or like operands, which is the plus sign for addition, the minus sign for subtraction, the star for multiplication, or this slash for division. And you would write it as how you see this in Python. So you could just like type out 4 plus 5, and if you click enter on whatever IDE you're using, then it'll come out as like 9, or 10 minus 3, that would be 7, and so on for the other arithmetic operations as well. We also have two other kind of more fancy operations, which is floor division and modulo. Floor division is an operation that will return the quotient as a whole number. And the operand for this would be 2 slash signs. So for example, we could have 17 divided by 7, where this would return 2 because 17 divided by 7 is 2 remainder 3. So it only takes the whole number and returns that. On the other hand, modulo is the operation that returns a remainder. So here, for example, if we have 21 modulo 4, this is the same. Well, you can think of this as like 21 divided by 4, which is 5 remainder 1. So this modulo function would return the remainder as 1. Our next topic is about variables. So variables in programming is very similar to how we have variables in math. So we can use variables to store data. And the variable assignment can be done with the equal sign. For example, we can have a variable called a, and if we want to set its value to be 10, we write a equals 10. And then we could also have other variables such as b equals 20 or c equals 30. And we can also reassign the values in variables just by using that same variable name and then reassigning it to a different value. So after this first section of code here with A, B, and C, anytime that you reference these variables, it's going to have the value stored in it. So anytime you want to use A, it's going to already have 10 in it. For B, it's going to have 20, and for C, it's going to have 30. But after we reassign the value of the variable A to 20, then it no longer has the value 10, but it now has the value of 20. We can also perform operations with variables. So let's take a look at this example here, where we have a variable A assigned to the value of 10. And if we want to perform A plus A, this is going to return 20. However, the second line in itself doesn't assign any values because, as you can see, there are no equal signs here. So if we want to actually reassign the value of the variable A, we would have to use the equal sign, as in this case here. So here, this would actually store the new value of A as the sum of A plus A. We have a couple of rules for what we can use to name variables. So for example, variable names can't start with a number. We can't have spaces in variable names. So the way that we kind of like work around this is by using underscores, such as like instead of my space name, you would do my underscore name, or just without the underscore or space at all, and just have it be one word. We also have some symbols that are restricted and that we can't use in our variable names. So this could be like the quotes, the commas, the carets, the slash, or any of these other symbols. And as kind of a rule of thumb, we try to avoid using single letter variable names that might be confusing if they look like any other numbers. So this means avoiding the letter L, the letter O, or the letter I, because this might make it confusing in our programming. And we also avoid using words that have special meanings in Python, such as list or string, because these have a reserved use in Python, and it's going to break your code. And the last thing is that we try to use lowercase letters in our variable names for Python, just as a general rule. So you can usually use any variable name that you want, as long as you're following those rules we listed earlier. But it's recommended to use variable names that have some kind of meaning in the context of your code, because this will help you with debugging and with understanding what your program is actually doing. So for example, I have this little snippet of code here where I have a variable called income, and it stores the value of 1,000. And then I also have a variable called tax rate with the value of 0.2. And I have a variable called taxes, and I'm going to store this with the product of income and tax rate. So as you can see, this makes it really easy to see what exactly we're trying to do in this program. And it makes it easy to understand what each variable is storing and why we're using these particular values in our multiplication. So we just have a quick note about errors. Errors can happen to anyone. It actually does happen to everyone. So for those of you who are beginners with programming, please don't feel discouraged if you come up with errors while you're writing code, because this is super common and it gets better with more practice as you come to recognize what errors you've come across before, and you remember what steps you took to fix those errors. You can also go through your code manually to find out where the error happened and why it happens. And you can always Google the error message that you come up with, because there's always going to be sites like Stack Overflow that have other people who have come across the same error, and it'll probably show you how to fix it. So with that said, we have our next topic. Does anyone have any questions about numbers or variables or anything that we had just covered? If not, that's totally fine. We can move on with our next topic. Okay, so this topic is about strings. Strings are a combination of characters, and characters can be singular letters or numbers or symbols. And strings are defined by a set of quotes, and this can be either the single quote or the double quotes. So, for example, this string that says hi, that's a string, or this whole sentence can be a string, or this sentence with double quotes is also a string. Something to take note of is that you might come across with errors when you're using contractions or apostrophes, because this might confuse the program into thinking that the string would end before you're intending for it to end. So for example, here, the string is defined by the opening and closing quotes. So if you have a sentence like I'm using single quotes, with the single quote convention, then this will come up as an error, because it's going to see this apostrophe here and think that this string has closed at the beginning here. So the workaround for this would be to use a combination of single or double quotes wherever you need it. So if you have the string, this shouldn't create an error now, because we're using double quotes, and the apostrophe is a single quote that's nested between this pair of double quotes. All right. We also have some built-in properties for strings in Python. So for example, we have a function called len, and what this does is it returns the length of a string that we have in the parameters. So for example, if we have the string apple and we call len on the string apple, then it's going to return 5, because 5 is the length of the string, or the number of characters that we have in the string. If we call len on our string good morning, then this is going to return 12, because it counts that there are 12 characters inside of the string. We also have a function called print, and what this does is it prints content to the console. So whatever string that you put inside the parentheses, it's going to print that out. And this is really useful for things like print debugging, if you want to check out what some variable is storing at some particular time in your program. Yeah, so strings, as we said earlier, is a combination of characters, and this can be thought of as a sequence of characters. So we can use indexing in strings to access individual characters within a string. And what this means is that each character is assigned a different position inside of the string, and that position has a number, which is the index. And Python strings follow zero-based indexing, which means that the index numbers start at 0. So for example, if we have a string storing the word university, then it would have index values from 0 to 9, where 0 marks the first character in the string, and then 9 marks the last character in the string. And this is kind of what the layout would be like for this string and its indexes. Yeah, so the way that we use indexing is by using these square brackets. And inside of the square brackets, we're going to put the index number of the character that we want to access. So for example, if we want to access the first character in a string, we're going to use the variable name. In our case, the variable name is myString, and the index that we want is 0. So we're going to write myString, open square bracket, the index number, which is 0, and then close square bracket. And if we run this line of code, it's going to give us the character at index 0, which in this case is the letter U. And the same goes for any other index position inside of our string. So if we want to access the character at index position 1, we would do the same thing with 1 inside of the square bracket, and that would give us the letter N. And if we want to access the character at position 2, this will give us letter I, and so on, so that position 9 has the letter Y. All right, so we can also reverse index a string. And what this means is that we can use negative numbers to go backwards inside of a string, where -1 is the last character inside of a string. So if you were to index my string at -1, this will give you the last letter, which is Y. And if you wanted to get my string at -2, this would get the second to last character, which is letter T. So we can also use slicing in cases where we want to select more than one character at once from a string. And the syntax for this would be the variable name, open square bracket, beginning index, colon, ending index, and then end square, close square bracket. And as a default, if the beginning index is not provided, then we're going to assume that we're collecting from the beginning of the string, which is from index 0. And if the end index value is not provided, then we assume that we collect until the end of the string. So, for example, in this first example, if we're collecting my string with no values entered between either side of the colons, then this assumes that we're collecting the entire string from the start till the end. So this is why we have the whole string university here. And then for the next example, we see that we don't have a number in front of the colon, so we start collecting from index 0. But then the number after the colon is index 5, which means we're going to continue up until index 5. And what this means is that we have 0, 0, 1, 2, 3, and 4 as the indexes that we're collecting, I, V, E. And so that's what we have here. We covered reverse indexing earlier, so it also works for string slicing in Python, where we can grab everything up until the last letter by accessing my string with starting from the beginning until a -1. And what this will return is the entire string except for the last letter, which is Y. So here are some more examples of string slicing in Python. Here we have 3 as the number before the colon, which means that we're going to start collecting from index 3. And we don't have any number after the colon, which means that we're going to collect until the end of the string. So because of this, we have VERSITY, which starts from index 3 and then collects until the end of the string. If we have something like my string from 2 to 7, then this will start from index 2 and then keep going until right before index 7. So this gets 2, 3, 4, 5, and 6, which is IVERS. So that's what we have here. We can also move in different step sizes in string slicing. So as a default, we collect in single steps. But if we want to specify the step size that we want to take, we can do this by adding an additional colon to our slicing formatting. And then after that colon, we'll have the step size that we want to take. So just like the base case would be my string for the entire string, which has the empty values in between the both sides of the colon, and then 1 as to indicate step sizes of 1. If we wanted to go in step sizes of 2, this would skip over every other index. So this would get U, I, E, S, and T as the letters returned. We can also really easily reverse the string by using negative step sizes. So to do this, we would have -1 as the step size value. And what this does is it flips the string around so that it's now backwards of the order that it was before. So it's also important to note that strings are immutable. And what this means is that once a string is created, we can't edit individual characters inside of the string. So doing something like this, where we're trying to access specifically index 0 of the variable and changing it to be a different letter, this would cause an error. So remember, we could reassign variables to have different values, but for strings, we can't change specific characters. We would have to change the string in its entirety if we wanted to make it have some other characters. Another thing that we can do is string concatenation, which is kind of a fancy way of saying that we want to combine multiple strings together. So for example, we can combine different strings by using the plus sign. So if we have a variable myString and we want to combine it with another string, then we'll use the plus sign, and this is what would be output from that. And again, doing this in itself doesn't really change any of the variables. We would have to use actual reassignment to explicitly change the values of any variables that we have. So here I could reassign my string to be my string plus Callie, and then afterwards, when I print my string, the variable, it'll show the updated and concatenated string. So in Python, we have a lot of built-in string methods that we can work with. And these are usually accessed using the dot notation format. And what this is the name of your variable, and then dot, and then the method name, and then parentheses. So that's how you would be able to use any built-in method that we have for strings in Python. An example of a built-in string method is the upper method here. And what this does is it converts all of the letters in our string to be uppercase. So for example, if we have this string that says University of California, and it has a mix of upper and lowercase letters, if we were to run myString.upper, we would get this, which says University of California, where all of the letters are in uppercase. And similarly, we also have a method called lower, and what this does is it converts all of the letters to lowercase. So if we were to run myString.lower, it would return all the letters of University of California in lowercase format. All right, so that's our section on strings. And we're going to do a quick little activity to kind of review what we've been learning about strings. So this is something that you guys can kind of think about. But for example, we have the question, given the string Amsterdam, write a Python statement that displays the letter D. And as a hint, this requires indexing. So we can do this by assigning a variable name to the string, and then using indexing to pick out the specific index number that we want and that has the letter D. So in this case, it should be at index position 0, 1, 2, 3, 4, 5, 6. So if you were to assign a variable name with this value Amsterdam and access it at index 6, this should be the solution for this first question. The second one says, reverse the string Amsterdam using slicing. So if you recall, we can use slicing to reverse strings by using the -1 number after the double colon thing. And for number 3, given the string Amsterdam, display the letter R using negative indexing. So if you recall, we can use negative indexing to travel backwards in string indexes. So -1 would be letter M, -2 would be A, -3 would be D, and -4 would be R. Yeah, so that's how you would get the letter R. So here we have our Colab notebook, so here's our Colab notebook, and we can use this to run code. So we can edit our code here. Yeah, but how it works is that you should be able to write code in here and then click the run button and it should run the code. So for example, our string is S and it has the value Amsterdam. So if we want to print out the letter D here, then we could access S at index 6. And so if we run that, then it returns the letter D, which is what we wanted. Yeah. And then for the second question, it says to reverse the string Amsterdam using slicing. So the way to do this is by using the double colon notation that we learned earlier, and then using -1 to reverse the string. So here we have the variable name of the string as S, and we can use this double colon notation and -1 as the step size to reverse the string. Yeah, so that works. That has reversed the string. And then this one says to display the letter, it should be R, display the letter R and use negative indexing. So the way we do this would be to go backwards. So we're going to count backwards where M is -1, A is -2, D is -3, and R is -4. So if we access the index at -4 for the string, then it should return letter R. All right, nice. So that's the now try this exercises for strings. And that was a quick review of what we just covered. So the next topic is going to be about Booleans and comparison operators. If you guys have any questions, you guys can type them in the chat box. Yeah. All right, so I'm gonna keep going with the content then. The next topic that we're going to cover is Booleans and comparison operators. So Booleans are another data type, and this can represent either true or false. And this is especially useful for if we have true or false questions and we want to check for inequalities or equalities of like, are these two things equal or are they not equal? And it's very similar to how it would be used in math. But the way that we would assign variables with Booleans is by having the variable name and then equal to either true or equal to false. And this would assign a Boolean value. We can also use none as a placeholder in the case that we don't really know what the value should be at the moment. And this is kind of like a null value for unknown status. We also have comparison operators, which are very similar to how they are used in math. And these are used to check for equalities or inequalities. So the first one that we have here is the equal operator. And this has the operand of equal equal. And this checks if two numbers are equal. So note that this is different from the single equal sign, which would be used for variable assignment. If you want to check if two numbers are equal, then you would use the double equal sign. And if you want to check that two numbers are not equal, then you could use the syntax of exclamation point and then equal sign. So for example, we would have like A is not equal to B as something that we would want to check out. And then our other ones are greater than, less than, greater than or equal to, or less than or equal to. And these are very similar to how they are used in math. So I'm going to skip over that. Oh. And here we have like a couple of Boolean exercises. So for example, if you were to write 4 = 4 in Python, this would return true because it's going to check if 4 is equal to 4. And since they are equal, it's going to return true. If you have something like 1 = 0, then it's going to check, is the value 1 equal to the value 0? And since these are not equal, this is going to return false. The same goes for not equals. So if you have 4 not equals to 5, this is true. If you have 1 not equals to 1, this is false. And the other ones for greater than and less than, they follow as well. Yeah. So our next topic is if-else statements. And if-else statements are used if we want to perform specific actions conditionally. And what this means is that we choose specific tasks to perform if some criteria is met, and we choose to do something else otherwise. So the syntax for this would be to have an if statement that says if, and then some condition, followed by the colon. And then the code for this block would be indented under the if statement. So it would be something like this. And then we could also have the else case, which says else and then the colon, and the code for the else case would be underneath the else block. So the way that this works is that the code checks the condition, and only if the condition is true, then the code for the if case would be run. Otherwise, it would run the code under the else block. So for example, if we have a variable called age and we set it equal to 18, and we have the if case that says if age is more equal to 18, then print you can vote. Otherwise, we're going to print you can't vote yet. So in this case, if we walk through the code, we have age is equal to 18, and we're going to check if age is more or equal to 18. And since this is true, we're going to go into this block that prints out you can vote. And it doesn't go into the else block because the first condition was true. We also have elif statements, which can be used if we want to check multiple conditions in Python. So the way that this would be used is we would have an if case, and then we could have one or more elif cases that go in between, and then finally we could end with the else case. But what this means is that we first check the if case, and then only if the first condition is false, then we go on to the next case. And then if the elif case is also false, then we go on to the else case. So it has to go in that specific order. So let's check out this example that we have, where we have the variable age equals to 18, and we're going to check the first condition that says if age is more or equal to 35, then we're going to print you can run for president. So since age is 18, it's less than 35. So this condition is false, and we're going to go on to the second condition, which says if age is more or equal to 18, then print you can vote. And this satisfies this condition for age is more or equal to 18. So we're going to print out you can vote, and we do not go on to the last else case. We might also have conditions or situations where we have multiple conditions that we want to check. The first use case could be if we want to make sure that both or all conditions must be true before running some code. In this case, we would use the AND operand. The second case could be if we want at least one condition to be true before running some code, then this would be using the OR operand. And here we have a little example of how we could use case 1 with the AND operand. So here we're going to check if age is more or equal to 18 and citizen equals to true, then you can vote. So from this line of code, we would have to make sure that both conditions are satisfied. And these conditions are that age is more or equal to 18 and that citizen is true. So both of these would need to be true in order to print out you can vote. Otherwise, if either the age is less than 18 or if citizen is false, then it would go on to the else condition that says you can't vote yet. For case 2, if we want to check that at least one condition is true before executing some code, then we would use OR. So there's a typo here. Yeah, but that should say OR. And it would be, in this case, we're checking if age is less than 18 or if citizen is not equal to true, then we would print out you can't vote yet. So only one of these conditions has to be true in order for us to print out this statement. But if both of the conditions are false, then we would go on to the else case. All right, so now we have I'll try this exercise. And it asks to write a simple program that decides whether you stay dry or wet when it's raining outside, or if it's not raining outside. So here's what should happen. If it's raining outside and you have a jacket, then we're going to print you can go outside. But if it's raining outside and you don't have a jacket, then we're going to print you're going to get wet. And then if it's not raining outside, then we're going to print it's a beautiful day. And these are the Boolean variables that we have. Okay, so here. Let's first handle the first case. So we're going to check if it's raining outside and if we have a jacket. So in this case, both of these conditions need to be met for us to print out the string, you can go outside. So this would have to be if raining equals true and jacket equals true. And we're going to have the print statement that says you can go outside. We also have another case that says if it's raining outside but you don't have a jacket. So we only want to run this if the first condition has returned as false. So we're going to use the elif statement that we learned about. Elif raining equals true and jacket equals false. Then we're going to print out you're going to get wet. And then another case that we have is if it's not raining outside. So if raining equals false, then we're going to print it's a beautiful day. Yeah. And the variables that we are given is that it's not raining and that jacket is equal to false. So we don't have a jacket. So if we walk through this code that we wrote, it's going to first check this first conditional that says is raining true and is jacket true. So we have raining as false and jacket as false. So both of these are false. And so we can't run this statement because this conditional entirely is false. So we're going to move on to the second condition, which says, is raining true and jacket false? Well, we have jacket as false, but raining is also false. So even though one condition is satisfied, we would need both of them to be true in an and condition in order for us to print out this line. So since at least one of them is false, we have to say this whole thing is false. And we go on to the last one, which says, is raining false? And it is false, so we can print out it's a beautiful day. Yay! Okay, so that was the now try this exercise. And we can go on to our next topic, which is lists. And this is our last topic for today. If you guys have any questions, you guys can chat in the comment box again. So Livia says, okay, so we have a question that says, do you have to put a space between each elif line? And I think this is referring to, are you referring to like this empty line here? So in Python, generally empty spaces or like new lines, such as this, are optional. So it doesn't make a difference if we have a new line here or if we don't. It's still going to run the same thing. It's still going to come out as the same output. but we do have to be mindful of tabs in Python. So for example, if we don't have this indentation here, that's going to come up as an error. Because in Python, the indents are really essential to where the code placement is, because that's how we know which code belongs for which block. So everything that's indented underneath this if statement is going to belong to this conditional, and everything indented under this elif statement is going to belong to that statement. So we could also have like an additional print statement here that says hello. And so if this case is true, then everything underneath that condition and that's indented underneath that condition is going to be run. So this is going to run both of those lines. Yeah. Does that answer the question? Awesome. No problem. Okay, so we're going to go on with our next topic, which is lists. And yeah, lists are a data type that can hold many types of data. So if you recall, as we were talking about strings, we mentioned that strings can be thought of as a sequence of characters. So lists are kind of similar in that they can hold multiple pieces of data at once, but the difference is that it can hold many other types of data, not just characters. So the format for creating a list would be to use a square bracket, such as this, and each item inside of the list is separated by a comma. So for example, we could create a list of integers that stores the values 1, 2, and 3, and we could save this to the variable mylist. And this would create a list that has 3 items. That's 1, 2, and 3. But we could also create a list that has multiple different types of data types. So it could be a list that has a string and also an integer and also a float and also a character. And that would also be a valid list. So lists also share many of the same properties with strings in that we can also use indexing and slicing with lists. And we also have the len function to get the length of a list. So for example, if I have a list that's defined with the values 1, 2, and 3 as strings, and then 4 and 5 as integers, that would still be a valid list. And if I were to call the len function for the variable mylist, this would return the value 5 because there are 5 items inside of the list. We can also use indexing for lists, where if we, for example, want to get the first item inside of the list, we would do this by accessing the element at index 0. And in this case, this would return the first item, which is the string that says 1. We can also use slicing, which selects multiple items at once. So if we do mylist and slice it beginning at index 1 until the end, then this will start at the string 2 and then collect until the end of the string or the end of the list. So it will give us 2, 3, 4, and 5. And that's what we have. And then for the next example, we have slicing from the beginning because there's no value given. And then we're going to stop right before index 3. So it's going to give us index 0, index 1, and index 2. Yeah, so this should be a typo. This is a typo, but it should give us 1, 2, and 3 as the values that are returned. And we can also concatenate lists together if we want to combine multiple lists into the same list. So for example, I could use the plus sign again to concatenate. And I could have my list, which is the list that I have defined up here, and then add a new list to it. This is a new list because it also has the square brackets, but this second list only has one item. So if I were to concatenate these two lists together, it would give us 1, 2, 3, 4, 5, and then the second list at the end. And that has new item. So if I reassign this entire part into the variable myList, it's going to give me this brand new list that has 6 items. All right. So another difference between lists and strings is that lists are mutable, which means that they can be changed after creation. So if you guys remember, we said earlier that strings are immutable. So we can't edit individual characters of a string. We would have to reassign the entire string if we wanted to change any particular character inside of it. But for lists, we can use indexing to pick out specific elements inside of our list and then edit their values. So for example, if I have a list that has the values hello, 1.2, O, true, and 5, and I want to pick out the element at index 3, that would be 0, 1, 2, 3, so that's this guy, and I want to reassign its value to be false, then that's a totally valid operation. And if I were to print out my list, the contents would show the same exact list as before, except that instead of the value true at index 3, we now have the value false. Yeah. So we also have a couple of other basic list methods that are built in Python. For example, we have the method for append, and what that means is that we can add an additional item to the end of our list. So if we have a list that has the values 1, 2, and 3, then we can call mylist.append and insert the string append me inside of the parameters. And what this does is it adds that new string to the end of our list. So now the list would store 1, 2, 3, and then our new string. We also have a method called pop, and what this does is it removes the first item from the list. In this particular example, it would remove the first item. And this is because we are specifying the index that we want to remove from. So 0 indicates the first index, so that's why it removes the first item. And if we were to run mylist.pop for index 0, this would get rid of the first item here. So we would only have the values 2, 3, and the string append me. For lists as well as strings, I guess, we also need to be careful of our index values. So if we were to try to access an index that doesn't exist, that would come up as an error. In this case, our list only has 4 items. No, it only has 3 items at this point. So if we were to try to access the index 100, this would come up as an error because Python would recognize that it doesn't have 100 items, and you can only access the indexes that currently exist for that list. We have some other built-in list methods. So we have the sort method, and what this does is it sorts a list in alphabetical order or numerical order, depending on what we have inside of our list. So for example, if we have a list that has all characters, so for example, list 1, and if we call list1.sort, then this would alphabetically reorder every item inside of our list, which you can see here. And if we call the sort function on a list that has numbers, then it's going to numerically reorder all of the items in ascending order. So as you can see, this is what list2 started as. And if we call list2.sort, then this would be what the output is. We can also choose to sort the list in reverse order. So we would do this by writing reverse equals true inside of the parameters for sort. And what this would do is it flips the order of the way that we're sorting our list. So as you can see here, list 2 is now flipped so that it's in descending order if you call sort for reverse equals true. Another way that we can reverse lists is by just using the reverse function. So for example, list1.reverse, this would reverse all of the items inside of our list. So these two are two different ways of doing the same thing. All right, so the next topic that we have is nesting lists. And this means that we can nest lists so that we have multiple lists within other lists. And this essentially creates a matrix. So for example, let's say we have these three lists, list 1, list 2, list 3, and they have these numbers. So we can also create a kind of wrapper list that has all of the lists inside as individual items. So if I were to create a variable called matrix as a list, where each item inside of that matrix list is the individual list, then this is kind of what the structure would come out with, where we have a list and we have like other lists within it. So if we wanted to access specific elements inside of our nested list, then we would need to use multiple indexing. So this is the example that we had earlier, where matrix is our giant nested list. And if we were to grab the first element of matrix by doing matrix at index 0, then this would give us the entire first list, which has 1, 2, and 3. But if we want to grab just an item from list 1, we could do this by using double indexing. So we would have matrix at 0, which, as we saw earlier, had returned the entirety of list 1. And then from there, also access the first index, and that will go within list 1 and access the first item of that list. So that will give us the value 1. And you can try that out for any of the other index positions as well to kind of play around with what values you're trying to get. All right, so now we have our now try this exercise, which I'm going to go over here to write the code for. Okay. So the first question says, using any way that we've learned, build the list 0, 0, 0. So if you recall from what we were talking about earlier, the way that we create lists is by using the square brackets, where each item in the list is separated by a comma. So that could be how you create the list. All right. So the next question says, modify answer 2 and use multiple indexing to replace hello with goodbye. So this is our answer 2, and this is actually a nested list because we have the outer list that has the value 1, 2, and this entire list inside of it as the third item. So the question says to replace the string hello with the string goodbye. So if you recall, we learned about multiple indexing. And to do this, we would use like multiple square brackets to index different parts of the lists that we have. So first, let's kind of play around with what we could be able to get out of this. We know that we want this at some point, right? Like we want to be able to get inside of this section. And from there, we know that this is the element at index position 2 inside of this entire list. So if I were to access this list, answer 2, which is this entire list, but choose position 2, because Python is zero-based indexing, so this is index 0, this is index 1, and this entire string is index 2. So if I were to grab that section and run that, then as you can see, that returns the entire list, the entire inner list that we want to work with. So from there, we know that this represents the inner list that we have. So now that we want to choose specifically to work with the hello part of it, we're going to check out which index that is. And we know that's index 0, this is index 1, and this is index 2. So we're going to grab answer at position 2 and 2. So like double indexing. And if you run that, then you can see that that correctly grabs the string that we want, and that's the string hello. So the question is to replace the string hello with the string goodbye. So the way that we would do this is by reassigning it. So we know that this grabs the string hello, so we're going to use that and then set it equal to goodbye. Yeah. So now when we print out the output of answer 2, this should show us the same list and nested list that we had earlier, but instead of hello in there, we now have goodbye because we swapped it out. Yeah, so that's the solution. All right. The last question is to sort this list using any method. So we learned a couple of methods of sorting lists, or we learned one, but it would be to do that, to run the sort method. So you would do answer3.sort with the parentheses, and then that prints out the sorted version of answer 3. Okay, so that's the last question that we have for the list section. And that's also the last topic that we're going to cover today. So that's all of the content that we're going to be covering today. But on Thursday, I'm going to be going over the homework for this topic. And also next week, we're going to be going over the second part of Module 1, which is more of the intro to Python stuff. But I think that's the end of the content that I have. If you guys have any questions, you guys can feel free to type into the comment box. And thank you all for joining. This has been really fun. So have a good night.